Sorry about that. Hello, welcome back. It's time for a second example of how to do a mass stoichiometry problem. Here we go. Balanced chemical equation. We have sulfur, whose formula is S8, combining with fluorine. Yeah, that's a coefficient of 24. Holy moly. Producing 8 moles of sulfur hexafluoride. If 47.4 grams of sulfur hexafluoride are made by this reaction, what mass of fluorine did it start with? Step 1, let's identify that given quantity and the unknown quantity. The given quantity has a mass of one substance specified. Hey, that would be 47.4 grams of sulfur hexafluoride. Be careful, I almost stopped at sulfur. No, sulfur hexafluoride is the name of a substance. That's our given quantity. This is going to be the one that our calculations begin with. Where would be the unknown quantity? The one being asked about, we're being asked what mass of fluorine did it start with? What mass of fluorine? So the fluorine is our unknown. I'll put the question mark above that one to denote that this is the one we're trying to determine the mass of by doing this problem. Dust bunny. All right then, so what's our first step? Identify the given quantity and unknown quantity. Hey, I have already done that. We are given 47.4 grams of sulfur hexafluoride, unknown, or what we're being asked about, mass of fluorine. 2, take the given quantity and change it into moles using that little conversion diagram. There's that conversion diagram. How do we change from a mass, 47.4 grams, to moles? We divide by the formula mass of that substance. So here we go. So let's take our 47.4 grams of sulfur hexafluoride, SF6. Once again, that 8 is not part of this step. No. 8 just means 8 moles of this substance. 8 is not part of that substance. To change this into moles, we're going to divide it by its formula mass. Oh boy. What's the formula mass of sulfur hexafluoride? Well, let's see. Where are you, sulfur? Sulfur, there you are. Your mass is 32.06, and fluorine is 19.00. So I'm going to take 19.00 and multiply it by 6. I'm going to add to that the mass of sulfur, just one atom of sulfur, which is 32.06. 32.06. I'm going to get 146.06. And there we go. So 47.4 divided by 146.06 is going to give us this nice number, 0.32452. And what are the units? That's going to be moles of this substance. Moles sulfur hexafluoride. There we go. Great. There we go. Next step. Step 3 on the steps that I gave you. Take the moles of the given quantity and use it to determine moles of the unknown. This is where we need the coefficients from the balanced chemical equation. Okay, so let's now do that. Let's take these 0. Here, different color. Got to change up them colors so I can differentiate the steps. Let's get everything on camera too there, Mr. Mobbit. 0.32452 moles sulfur hexafluoride. Set up parentheses. Put sulfur hexafluoride on the bottom. It works. Trust me. And we're going to put our unknown on the top. What's our unknown? We already marked it. It's F2. Now let's give each of these formulas here their coefficients. F2's coefficient is a big whopping 24. Yeah. I don't think I've used an equation with a coefficient bigger than 24 ever. Sulfur hexafluoride's coefficient is 8, ocho. Great. Now we can work this out. There we go. 0.32452 moles times 24 divided by 8 equals I'm going to squeeze this in, 0.97357 moles F2. One more reminder is that this number here and this number here are not final answers, so I left lots of decimal places, about 5. 4 or 5 is good. You don't want to round these off and cut them too short. 0.3 is actually quite different from 0.32452. 0.9 is very different from 0.979. And if you were to just round this to 1, you'd be robbing yourself of a lot of accuracy, so don't do it. Next step, what does it say? Take the moles of the unknown quantity and convert it to grams by using that diagram. So let's take this number now and bring it into the next step. 0.97357 moles, and we're going to convert that. I'm sorry, 0.97357 moles of fluorine. Let's convert it into grams of fluorine. Once again, how do we go from moles to grams? Aha. We have to take the moles, multiply it by the formula mass of the substance. That'll give us grams of that substance. So we're going to multiply this by the mass of F2. Fluorine on the periodic table says 19.00. Oh, come on, focus. Help me out here. There it is. 19.00 when rounded to 2 decimal places. And 2 times that would be 38. 38.00. So we're going to get our final answer. 0.97357 times 38. Shaboom. Final answer, 36.995. You know what? I'm going to round that to 37.00 grams of F2. And there it is. Remember, in your answer, a number by itself is not enough. Include grams, G for grams, or the word grams, and the formula of the substance. Remember, these problems start off with a mass of one substance, but by the end, you're reporting the mass of another substance in the equation. Coefficients, like the 24 and the 8, only get used one time, and that time is in this middle mathematical step right here. There's no coefficient of 8 up here. There's no coefficient of 24 down here. The coefficients only get used there. Also, these intermediary mathematical answers aren't the final answer, so leave decimal places there. Don't worry about sig figs or any of that stuff. And I think that's it. Email me with any questions you may have. I hope you're doing well. And that means have a nice day.